Hi everyone, in today's video we will be talking about leveraging the power of vector search for root cause diagnostics in manufacturing using MongoDB and AWS. When we look through the lens of manufacturing industry, we see a complex value chain that spans from inventory management to connected equipment and products. Our clients use MongoDB for various use cases, and every day new ideas emerge. Today we will focus on one particular critical use case, root cause diagnostics. Why should we emphasize root cause diagnostics in manufacturing? Well, root cause diagnostics is essential for solving problems, improving processes, and boosting overall efficiency and quality. Unlike predictive maintenance, which focuses on symptom management, root cause diagnostics digs deeper to identify the underlying causes of issues, ensuring they are fixed permanently and do not recur. Root cause diagnostics offers several benefits. Eliminates recurring problems. By addressing the true root cause, we avoid temporary fixes and prevent the same issue from reoccurring, saving time, money, and resources. Enhances process efficiency. Identifying bottlenecks and inefficiencies at their core leads to increased output and lower production costs. It also promotes safety and environmental practices. Proactive interventions and risk mitigations foster safer and more environmentally friendly operations. And finally, drives continuous improvement. The systematic approach of root cause diagnostics encourages ongoing process improvements and innovation. However, implementing root cause diagnostics in manufacturing can be challenging. The vast amounts of complex and noisy data from sensors and machines, along with the need to integrate diverse data types, make it a daunting task. Traditional methods rely heavily on human expertise, knowledge, and experience. Generative AI can significantly enhance root cause diagnostics by offering several key advantages. Scientific objectivity. Gen AI is trained on vast amounts of scientific data, allowing it to analyze potential root cause with an objective, unbiased perspective. Exhaustive exploration. Gen AI can process large volumes of data, uncovering hidden trends, anomalies, and unexpected connections. Hypothesis generation and testing. It enables easy simulation of different scenarios and hypothesis testing. Missing expertise simulation. Gen AI can simulate a specialized expertise, providing unique insights and perspective. Remember, Gen AI is not here to replace human expertise, but to augment it. By working together, humans and AI can achieve faster problem solving, improved process efficiency, and more resilient manufacturing operations. To effectively carry out root cause diagnostics, we need a comprehensive information system that can not only identify what is broken, but also explains why it broke. This requires a complex set of data, including job status, sensor data, and tool information. With advancements in technology like transformers and vectorization, we can now capture and record diverse data types, such as machine sounds, in addition to unstructured data. This means we are dealing with both structured and unstructured data. This is where the power of MongoDB document model and Atlas vector search comes into play. With MongoDB, we can seamlessly integrate and analyze this variety of data. This allows us to extend traditional maintenance practice into AI-enabled root cause diagnostics by incorporating sensor data, sound samples, and generative AI. Now, let's move on to the most exciting part. How do we put this into practice? Let's explore the demo architecture and see how all comes together. In our setup, the engine is connected to a Raspberry Pi. The Raspberry Pi controls the engine through a relay, and it's equipped with sensors to measure telemetry data like temperature and humidity. When we turn on the car, from one of the apps, the command is sent to MongoDB, which streams it down to the Raspberry Pi, triggering the relay and starting both the physical engine and the virtual car. Now let's focus on a critical aspect, audio diagnostics. Every second, we record a clip of the engine sound. This audio is converted into a vector through an embedder and stored in MongoDB. Using Atlas Vector Search, we can predict whether the engine is off, running normally, or detecting a metallic or a soft hit. This information is then displayed on the apps. This capability is incredibly useful for manufacturing companies, allowing for feedback loop where the edge devices generate data for real-time control and monitoring, now enhanced with audio diagnostics through vectors. This is the power of leveraging vector search for root cause diagnostics. And lastly, we have integrated AWS Bedrock to automatically generate reports based on these findings. Whenever a hit is detected or the audio sounds abnormal, Atlas triggers a function to send the telemetry data and sound analysis results to Bedrock. Then AWS Bedrock generates a detailed report which is sent back to our dashboard, as you can see on the screen. By leveraging the power of Atlas Vector Search and GenAI, we can significantly enhance root cause diagnostics in manufacturing. This integrated approach ensures more efficient, reliable, and innovative operations, driving continuous improvement and long-term success. Thank you for watching. If you are interested in learning more, have a look at the resources in the description box below. Thank you so much and see you on the next one. Bye.